Hello friends, today we will see what is a Dijkstra shortest path algorithm, another greedy approach for solving a tree or a graph problem. Dijkstra shortest path algorithm, we will first start with an example. This works for a directed graph, that is, I have to show the starting and the ending point with the direction that I start from a source node and route to a destination. For this particular graph, we have taken S as the starting point and T is the terminating point or the destination where I have to reach by visiting each and every vertex or each and every node to find the shortest path if a person needs to travel from a source to a destination. The Dijkstra shortest path algorithm is another greedy approach for a directed graph, and the second criteria is it should not form a cycle. So when we work with Dijkstra, our graph should have weights, that is some value which needs to be assigned or some value which needs to be there for each edge, and there has to be direction from where I am traveling from one place to another place. As the prims and kruskals of greedy works with a non-directed graph, but Dijkstra to find the shortest path first, that is the shortest path algorithm, works on a directed weighted graphs where I have a source and a destination. This is an example of a graph which is being given. S is the starting point and T is a terminating point, and in between I have nodes 2, 3, 4, 5, 6 and 7 which needs to be visited, and when I visit all the nodes and from each node to each another node which is being connected with a direction will be considered and the values will be recalculated so that I find the shortest possible path to traverse from my source to destination without wasting much time and space. Let's start with S initially is empty, that is I have not started anywhere as from the source. PQ is nothing but all the distances that needs to be covered between source and destination. So in the PQ, it's just an array which has been named. We have stored S as a starting location and 2, 3, 4, 5, 6, 7 are the nodes which needs to be visited before I reach the destination or the terminating point T. All the distance level at present before starting from the source S have been assigned to infinity, that is any value, as I have not visited that particular node. So there is no distance that is known to me to travel from the source to that particular destination. So initially S also is been assigned a 0 weight as I don't know anything before starting, and all the nodes which needs to be visited is been assigned a value infinity. So we start with the Dijkstra shortest path first algorithm solution for this particular graph. Now let's start. S0 is my start point. Rest all nodes which needs to be visited have a distance label of infinity. We start with 0, and what do we have to do? From 0, that is from S, the source location, I have 3 nodes which can be visited, 9, 14 and 15. From the 9, 14 and 15, we mark as 9, 14 and 15 are the 3 nodes which can be visited from 0, and you will see the nodes which are visited are 2, 6 and 7. So the infinity value of those nodes are now changed to the weight of that particular edge, that is from S to the node 2. The weight assigned to that edge is 9. So the distance travelled from S to 2 is 9. So the infinity value is now been replaced with 9. From S I can visit 2, 6 and 7. The weights assigned are 9, 14 and 15. So all the 3 infinity values are replaced with the weight of the edges. So the infinity value of the node 2 is replaced with 9. Infinity value of node 6 is been replaced with 14 because that is the edge weight, and infinity value of edge 15, that is the node 7, is been replaced with 15. So the distance label is changed to the weighted values. But as it follows again the minimum spanning tree basics, and we are trying to find the shortest path. So out of the 3, 9, 14 and 15, we see which is the smallest distance value or the smallest weight value. As we get the smallest weight value, that becomes my new start. 9 is the shortest weight value. So from 9, 14 and 15, 9 becomes my new start. Now from this new start, how many nodes can I visit? If you see, from the new value 9, that is from new node 2 as my start node, I can visit is node 3. There is no other out degree, that is from node 2 I cannot travel anywhere else except the node 3. That is what the out degree arrow is showing. That is only one arrow which is going out from node 2. And the edge weight, that is from node 2 to node 3, that is vertex 2 to 3, UV value is 24. Already the value of node 2 is 9. So traveling from S to 2 to 3, the value will be 9 plus 24, which is equivalent to the value 33. So the node S and 9 are visited. So S and 2 are visited with the value 9, and the node value 3 is been decreased to 33. So you will see that in the array S, that is the source, the value S and 2 have been freezed over there. And from P and Q, the start and the node 2 have been removed. So whatever nodes we will be visiting, those nodes will be adding in S, that is from source how we are traveling, and wherever we are visiting will be removing from P and Q. So from 2 to 3, the edge value was 24, and so the infinity value from infinity has been decreased to 24 plus 9, which is equivalent to 33. Now, from 33, I have 3 nodes, 33, 14 and 15. From 33, 14 and 15, I again take the shortest path. So the value 14 is considered. Now from 14, where all I can travel? The out arrows from 14, that is from node number 6, goes to, from 6 I can travel to 3, from 6 I can travel to 5, and from 6 I can travel to 7. So these 3 nodes can be visited from my new start node or from my new start source position, where I can find the shortest path first. So what do I do? When I visit from the new node 6 to 5, the infinity value is 14 plus 30. So the infinity value is replaced with 44. And from the new node 6, that is 14 plus 18, which gives me a value of 32 if I traverse from node 6 to node 3. As I was traversing from node 2 to node 3, the value was 9 plus 24, which was 33. But if I am traveling from node 6 to node 3, my distance reduces from 33 to 32. So the value of 33 is been replaced by, so the path to traverse node 3 is now not from source to node 2 and node 3, rather it is from source to node 6 and then to node 3, as it reduces my distance from 33 to 32. So we see that as 6 is the node from where I can traverse to 3. So in the source list, we add source 2 and 6. Now we have 3 nodes with a value 32, 44 and 15. We have not changed the value for the node number 7 as if I travel from 6 to 7, 14 plus 5 will make it 19. The distance will increase. So, it is better to traverse to the node number 7 from my source with a distance of 15. Now, I have three distances, that is 32 for node number 3, 44 for node number 5 and 15 for node number 7. Again, as we are finding the shortest path, so we consider now is node number 7 with a distance of 15. The blue shaded portion shows that the nodes which have been visited have now been fixed. We cannot change them or we cannot traverse back to those nodes. And now we start with node number 7. From node number 7, where all can we go? As 7 is my new start. From 7, you can see the arrows which are going out are to the destination, that is T. But I cannot reach the T directly as I have not visited the other nodes. My other two nodes are still remaining, that is node number 5 and node number 14. But the distance to the destination can surely be calculated and written. So from node number 7, I can go to T, and with 15 plus 44, the distance travelled to my destination is 15 plus 44, which is equivalent to 59. So that distance has been changed. Now from 15 plus 20, as node 5 had a value of 44 if I was traversing it from node number 6. Now if I traverse from node 7 to node 5, the value is reduced from 44 to 35 as 15 plus 20 will give me 35. So the shortest path to travel to node 5 is to come to node 7 and then come to node 5 as it gives me the shortest distance possible. So the new distance is being calculated for node 5 and the path is from start to node 7 to node 5 and the distance is calculated and written as 35. So again we have got a distance 59 if I travel to destination, but that is not my final path as I have not chosen other nodes also. I have not considered traversing to the other nodes. Now what do we do? So what happens is from 35, if you see the value to reach the destination, that to reach the node 3, if I traverse from 5 is 35 plus 2. So that is just not possible and it is showing me a wrong arrow. So I cannot travel anywhere from there. Now from 35 and 32, the two nodes that I have 32, 35 and 59. Which is the minimum? Minimum is 32. So 32 becomes my new start. And in the array S, I have the value S, 2, 6 and 7. So these are the three nodes which are fixed location or which can be traversed at the minimum shortest path to reach these three nodes. And the remaining nodes whose distance needs to be fixed on the shortest path are 3, 4, 5 and the destination or the terminating point T. As 32 is my new start. So from 32 where all I can go? From 32, that is the distance 32, the node number 3, I can traverse to the terminating point T and I can travel to node number 5. So the values can be recalculated as from node 3 to node 5 if I traverse 32, the distance between 3 and 5, that is the weight value of the edge 3 and 5 is 2. So 32 plus 2 is 34. So that value can also be changed to 34. And from 3 to the terminating point when I travel, the value is 32 plus 19, which is reducing from 59, I come down to 51. So the distance traveled is again reduced. So we take that when I have to reach the terminating point T, I can travel from source S to node number 6 with a value 14, to node number 3 with a value 32, and then with 19 the distance reduces to 51. And then what do? We have traversed these two, but still the minimum path is not yet found, as I have not yet visited my node number 4. It still shows me the value of infinity. When a node shows a value of infinity, which means that I have not visited that particular node, I need to traverse that node also. Now the nodes which are existing for me to traverse is 34, there is one infinity and the terminating point. So what do? The only new start for me now is 34, that is the node number 5. So node number 5 is my new start, and in my S, that is from source I can travel, the source node 2, 3, 6 and 7 have been added. The only nodes which needs to be fixed are 4, 5 and 3. As you see, we are traversing the blue chart area keeps on increasing, which says that I have found out this particular nodes as my fixed destination. And when I say node number 5 is my new start with a value 34, where all I can travel from 34? From 34, you can say there is an out degree from node 5 to node 4 and also from node 5 to my terminating or my destination. Now with 34, the value of node 5 is 34 and the weight on the edge to reach to node 4 is 11. So 34 plus 11 will make it 45. So my node value 4 infinity has been replaced with 45. Now if I travel from this node 5 to my T, what happens? 34 plus 16. What value do I get? I get a distance value of 50. So when I reach this particular terminating point, from my node value 5, it will be 50. So the new terminating value from 51 has been reduced now to 50. You will see the values have been cut and have been replaced with 50. So that is the distance which can be traveled. And then what do? From there, I have the value 45 and 50. Out of the two, again 45 is minimum. So 45 and node number 4 with a weight of 45 is my new start. In my source, I have in my S array, source array, I have S, 2, 3, 5, 6 and 7. My node number 4 is still to be visited or confirmed the path it needs to be traveling. So now 45 for the node number 4 is my new start. With this new start, I calculate my distance value to my destination. With 45 plus 6, it will make it 51, which is not valid, as 45 plus 6 will make it 51 and that will not be the shortest possible path, as it already has a value of 50. So what happens next? That particular value is left as it is, and the highlighted portion shows that source 2, 3, 4, 5, 6 and 7 are now in my source. And how do I reach this particular value of T? As we see that we've reached all the nodes, but the last node is still remaining. So how do we find the path? All the paths which are traveled are shown with a bold highlight so that we know where we are traversing. So for our final destination, when 50 becomes my final terminating value, so what do? I have traversed all the nodes starting from start to node number 2, 5, 7, 6, 3 and then reach to a destination 4 and then finally terminating the t value. When I reach the value of t, then what I do? All the highlighted arrows show that how the routes are traversed. To find the shortest path from source to destination, from S, when I start with a value of 0, it changes my node values of 2, 5 and 7 at the initial. It changes my values of 2, 6 and 7 in the initial condition, and then node 3, node 5, 4 and then finally reaching the terminating condition. So, the arrows which are shown over here as S is my final path to traverse all the nodes source 2, 3, 4, 5, 6, 7 and T. My PQ is empty, which shows that I have traversed all the nodes from source to destination, and highlighted values with their edge weights are shown as how we change the distance value when we traverse from one edge to another. So, if you will consider that when we are traversing from the source to destination, the node numbers which needs to be visited in the shortest possible paths are, if I need to travel only node 2, then it is directly from source to node 2. If I need to travel the node 7, then it is directly from source to node 7. But if I need to travel node 3, then as we've seen in the example, the best possible shortest path was to reach node 3 was from source to node 6 and then to reach node number 3. To reach the node number 5, we traverse from source to node 6 to node 3 and then to node number 5. Rather than, as it can show very easily in this graph, that we can travel from source to node 6 and node 5 as they look very close to each other, but the distances in between show that it is more feasible to travel from source to node 6, node 3 and then to node 5. The distances on the graphs which are shown may not be as per the practical values, as the distances shown and the pictorial representation may not be shown as on the graph on the scale of 1 by 1. So, when I have to reach node number 4, I have to travel from the source to node number 6 to node number 3, 5 and 4. Then I get the shortest path with a value of 45. And again, if I have to reach the last node, that is my destination, then the path to reach my destination is from source to node number 6 to node number 3 to node number 5 with a value of 34 and then to node number T, that is the terminating value, with a distance of 50. That is the minimum weight I can get if I traverse. And here, to reach each and every node, this particular Dijkstra algorithm is an implementation for the traveling salesman problem to solve that if a traveling salesperson has to deliver goods from source to destination and has various locations in between, then this particular algorithm is used for implementation. Thank you.